So this is the homework help video for Unit 11, Objective 2 for Honors Math 3. So I'm going to take a look at question number 4, but I'm not going to do the exact problem because there's only like one of each style, but I'm going to do one similar to that so you can kind of get that a little bit of extra practice. So this is, I'm going to just call this like 4b sort of. So similar, but not exactly. So we're going to do f of x is equal to x minus 2 over x plus 4. And then we are going to do this at x is equal to 3. Okay? So they're asking us to find the slope function for each of the following via the limit process. So that slope function, what they're referring to is we're going to find the derivative, right? And what does the derivative do for us? It creates a slope function so that we can find the slope of our curve at any particular point. Okay, so we have to do that. And then we also have to write the equation for the tangent line as well. And so just a reminder, so that equation of the tangent line, so that is given as y minus y1 and then equal to m times x minus x1. And remember, m is a numerical value, right? So when we get our derivative or our slope function, we are actually finding the equation to calculate the slope, right? And so we would have to evaluate the slope so it's a numerical value, right? So we wouldn't put in something like 2x. We would do 2x and then replace x with a number value. All right, so let's go ahead and start by finding the slope function. So we're going to take this guy right here. So we're going to do the limit as h approaches 0. And it really doesn't matter what variable you use. You can use h or delta x or any letter at that matter. But h and delta x are the typical variables that we would use for something like this. All right, so remember it's going to be a fraction, right? It's going to be a fraction, and our h is going to be on the bottom, so we're just going to go ahead and put an h. And then we have to find f of x plus h. So that is our original function, but modified, right? So it's the kind of uglier of the two, so the modified function. So I'm going to start with taking the x's here, right? Both of these x's, and I'm going to modify it by replacing them with x plus h. So instead of x minus 2, it's actually going to be x plus h minus 2. And then instead of x plus 4, it's going to be x plus h plus 4. So there is the modified form, right? Modified form. And then we subtract the original, right? So we look here and we want to subtract the original. So the original being x minus 2 over x plus 4. So in our Objective 1 homework, you practiced simplifying some of these. Some of you struggled with that a little bit, so I hope that you look at your Worksheet 1 solutions and compare them before you do your Worksheet 2, okay? Just because this is where it's very similar. All right, so now we want to clear our fractions. So that means I'm going to multiply the numerator and the denominator by my denominators, right? So my denominators being x plus h plus 4, and then the original, which is x plus 4. And then that's going to allow me to get rid of that complex fraction and simplify that a little bit, right? So then I'm going to go ahead and distribute to both of these in the top. So I will have the limit as h approaches 0. And then when I distribute the first two, the x plus h will cancel, right? Leaving me with the numerator, x plus h minus 2. And then, of course, this one canceled, so I'm only left with x plus 4. Okay. All right, so then now I'm going to distribute to the second one. So I have that subtraction, so I want to make sure that that's there. So then when I distribute to the x minus 2, in this case, the x plus 4 will cancel, right? Leaving me with x minus 2, and then the one denominator that didn't, which was x plus h plus 4. And then that is all over, and then h, and then those other denominators. So one of the things I saw was in the homework when I was kind of reviewing, those of you who had turned it in, is I saw a few of you like cancel like x plus h plus 4, right? But you can't cancel because of that subtraction. So that is not what we can do, right? We cannot cancel that. So we have to distribute and combine like terms in the numerator, right? So as painful as that is what we need to do, okay? So we're going to go ahead and distribute this out. So we're going to multiply x times itself, and then x times 4, and then multiply h through, so that would give us xh, and then plus 4h, and then multiply the negative 2 through, so that would be negative 2x minus 8. So again, this is tedious, but attention to detail is really important here, so don't rush through it. Take your time, okay? So that is that first group there. And then now I have to distribute that second group. And so I'm going to keep that subtraction there because I do want to keep that in the back of my mind that I have to distribute that negative. So now I'm going to do the same thing again. So I'm going to distribute the x throughout. So that would be x times itself, and then x times h, and then x times 4. And then distribute the negative 2 throughout. So that would give me negative 2x, negative 2h, and negative 8. And then I do not want to distribute that denominator because my hope is that some things will cancel, right? All right, and then I still have that limit out front. That doesn't go away. All right, so now I'm going to go ahead and distribute that negative, right? But before I do that, I'm going to take a look at the fact that a few of these things are going to cancel, right? Just to kind of save me a little bit of time. So I have a positive x squared that I'm going to subtract with x squared, so that will cancel. I have a positive 4x that I'm going to subtract with a 4x, so that will cancel. I have a positive xh, which will cancel because I'm subtracting here. And let's see, we have a negative 2x minus a negative 2x, so that will cancel as well. And then negative 8 minus a negative 8, so that will cancel. So it looks like almost everything canceled in the numerator, which it should, right? That's what should be happening. So then I'm left with this positive 4h, and then subtract, and this negative 2h. So again, a lot of attention to detail. Make sure you are taking your time with doing this style of problem. Okay, so let's combine like terms in the numerator. So then I'm going to have the limit as h approaches 0, and then this double negative will turn positive. Oops, that's an h there. And then the h's will reduce because h divided by h is 1. And so now once I do my reducing, right, so distribute, combine like terms, reduce, then we can go ahead and take that limit part. So any remaining h's will turn into 0. So that will be this one right here. And so then that will leave me with a 6 in the numerator, and then x plus 4 times itself. So that is what we call our slope function, but it is also our derivative, right? So derivative, slope function, same thing. All right, so now that we have that, we can actually find our slope. So for this particular problem, right, I modified it. So we're going to do x approaching 3. So I'm now going to find my slope. So let's go ahead and do that. So I'm going to do that next. So the slope function evaluated at 3, or the derivative evaluated at 3. So that will give me 6 over 49. So that's my slope. So then my equation, so now I'm going to go back and look at this equation. So I know x1, right, but I don't know y1. So I have to find y1 now. So I'm going to do that, y1 of x. So that's just the original equation, or f of x, right? So now I have to evaluate that at 3. So I'm going to find f of 3. Oops. So replace your x's with 3. So I would get 1 over 7. So now I have everything I need to write that equation for the second part of the problem. So it'll be y minus my value for y, and then my slope, and then x minus the x I used, which was 3. And that would be the second part of the answer. Okay? All right, so there is that equation. Okay, and then on number 5, I'm going to start you on that one, but I'm not going to work it out all the way through, just get you rolling on that one. Okay, so we're going to do the slope function again. So that's our limit as h approaches 0. And we know it's going to be a fraction with h in the denominator. And we know we're going to have our modified function minus my original, right? Modified minus original. So that original would be root x plus 2. And then that modified would be replace x with x plus h. So that would be x plus h plus 2. And then we have to simplify this. Okay, so I don't need those brackets, do I? Right? Because I don't have anything to distribute. because that square root kind of keeps it grouped already, so I don't need to have those, so I'm going to go ahead and get rid of that. And so then now what I need to do here, so because I have a radical, I want to multiply by the conjugate. So that would be root x plus h plus 2, and then instead of subtracting, I'm going to add. And whatever I do to the numerator, I also have to do to the denominator. Okay? All right, so then when I distribute, because it's conjugates, I only have to do first and last, right? So because it's conjugates, I only have to do first and last because the outer and the inner will cancel. So I still have that limit as h approaches 0. And then when I multiply roots together that are like, I will just get the non-root version of that, because that would be root of x plus h plus 2 quantity squared, and that root and squared would cancel. And then subtract, and then the same thing here, first and last. So I will be left with x plus 2, but I'm going to group this, right, because I want to make sure I distribute that negative. And then this would be all over h, and then root x plus h plus 2 plus root x plus 2. Okay, so let's go ahead and distribute that negative. And so what's going to happen here is I'm going to have x and then minus x, right? So that will cancel. And then I'll have 2 minus 2, so that will cancel as well. So that works out pretty fabulous, and that's in general what should happen every time you find the derivative, right, or the slope function, same thing. So most things should cancel, not everything, well, hopefully not everything, but occasionally I guess it could. There's certain instances where the whole numerator would cancel. All right, so then once I get there, I see that the h divided by h cancels, and as soon as I do that reducing of those h's, or delta x, then any remaining h I replace with 0. So this will be turned into a 0. And so then that derivative or slope function would be 1 in the numerator. And then I have root x plus 2 plus itself. So that would be 2 of them. So this problem isn't done, but that's just getting you started on slope function itself. So you still have to write the equation of the tangent line. So you still would have to find the slope. You would still have to find the corresponding y value and that whole thing there. Okay, but that's just to get you rolling. Okay, so let's take a look at the second group here, so 10 through 12. So we're going to take a look at number 11. So for this one here, so for part A, they want us to figure out where the slope function would not exist. So that would be anywhere there's a sharp turn or potentially some sort of vertical tangent, like right here somewhere. And that would be nowhere here, right? So there's no sharp turns. So there is, so every place it would exist. So there's no values of x where it would not exist. For part B, then we are finding the values of x where the slope function does exist. Well, that would be everything, right? So that would be from negative infinity to positive infinity. Okay. And then part C, where the slope is 0. So what we're looking for is any place where we would have a horizontal tangent. So that would be at your relative maxes and mins, right? So that would be at here, right? I would have a horizontal tangent at a relative max or min. So that would be at 1, 2, 3. So at x equals 3. And then for part D, we want to find our positive values. So that would be when our graph is increasing, right? So anytime we're increasing, then we would create positive slope. So let me, so that would be starting right here and going along this line, right? So if I were to put a tangent line anywhere here, it would be positive sloped. So our graph is increasing. That is where our slope values are positive. So that would start at 3. And then go all the way to the right, so to infinity. And then for part E, where would we have those negative values? Okay, so that would be everywhere a graph is decreasing, so everywhere a graph is decreasing. So starting here and then going to here. So some people, there might be potentially a slope equals 0 there, but we really can't tell for sure. So I'm going to just assume that that is negative. You learn more about how to find that specifically next year, but at this point, that didn't look flat enough for me to call that a 0. So then I'm going to say it's decreasing, right? Decreasing, so that's everywhere where we have those negative slopes, right? Everywhere there. And so that would be starting at negative infinity until I get back to that relative minimum, which occurred at 3. Okay, and that's it for this one.